Section 1.1.A-2. We're using the ideas in drawings A and B to find the solution to Gauss's problem for the sum 1 plus 2 plus 3 plus ... plus n, and then explain your reasoning. Okay, if we look at figure A, we can see that this represents n down here, and this also represents n. And over here, this represents n, which is the same thing. And then if you notice, everything in blue, we've seen that we've now added a 1. Now, when we're building a staircase, as seen in A, gives us a visual graphic of the sum 1 plus 2 plus 3 plus all the way to n. Now, copying the staircase in B and placing it as shown demonstrates that an array that is how many units high? Well, it's n units high, so we're going to say n units high. And how many units long is what's being produced? Well, over here, it's n plus 1. Now, there are how many units in B? Well, we're going to say that there's n, right? So we want to find the area of this. Okay, the area is the length times the width. So it's n times n plus 1 units in B, which is twice the number desired. So the sum of 1 plus 2 plus all the way to n must be the following. We're going to say that n times n plus 1 divided by 2. Okay? Now, let's just look at another example here. So let's say that this is what the staircase is. We have 100 blocks here, we have 100 blocks here. We have 100 blocks here, and now we have 101 blocks because we added 1. Now again, in part A, when the stack in A and a stack of the same size is placed differently next to the original stack in A rectangle containing 100 blocks times 101 blocks is created. Since each block is represented twice, the desired sum would be the following. So the desired sum is going to be 100 times 101 divided by 2, which would equal 5,050. Now, while the above represents a specific example, the same thinking can be used for any natural number n to arrive at a formula, which is what we get over here. So as you can see here, n represents 100. And then if you take a look at that formula, if we say that n is now equal to n times n plus 1 over 2, okay, we know that n over here is equal to 100. So if we substitute this to be n, we get 100 times 100 plus 1 divided by 2, which gives us the same thing that we get over here, which is 100 times 101 divided by 2.